Okay, so the next two pages, a lot of the old type stuff, although some of them are a little bit tricky with some of the stuff. But anyway, they're pretty straightforward. So hopefully you've gone and tried some of these and now you're just going to come back and check the answers. So they want to know which graph, we've got 4 graphs down here, represents a system of equations, and sure enough, there's 2 lines on every one of them that has no solution. Now remember, if the 2 lines intersect, the solution is where they intersect. That point is on both lines. So if they intersect, there's one solution. If they're parallel lines, there is no solution. And if they're on top of each other, that means you have infinite number of points on both lines, okay? But parallel lines have no points on both lines. I've got points on that one, points on this one, but no points that are on both lines, which is what we're looking for a system of equations to solve. So what's the only one that looks like they're parallel? This one. You may think, well, these are not touching. Yes, but if you extend them out here, will they eventually intersect? Yes, so these will eventually intersect. So there is a solution where they intersect. That these 2 lines are parallel and they will never, ever intersect, no matter how far they go. So D is the correct one on that. All right, so there's number 15. 16's up here in the corner. And they just want to know, what are the coordinates of the vertex? Well, of course, the vertex is down here where it changes direction. That little tippy point, we want the coordinates. And it's x, y, so ordered pairs always have the x number first, y number second. So that means I went right 1, positive 1, and down to negative 2. And you can also look for the x number of that point is 1, and the y number is a negative 2. So there it is, 1, negative 2. Double check these carefully, because sometimes you can get confused. Sometimes they give it much more tricky versions of this, with everything kind of mixed up, but with the 1s and negative 2s all mixed up with different signs. But anyway, that one wasn't too bad. 17, which expression is a factor of this thing, right? So, of course, normally what we would do, rather than doing it by hand, is put y equals in front of this and put y equals in front of the answers and then try to match them up. Well, when you graph this very first one, what was unusual was, did it ever cross the x-axis? No, it never did cross the x-axis. So if it doesn't cross the x-axis, are there any x-intercepts or solutions, right? Did I say that right? Okay, yeah, so there actually are no solutions to this one. So since there's no solutions, you can also, there aren't really any factors. None of these, it's not factorable, basically is what that means. So this one is not factorable. We haven't talked a whole lot about that, but the factors and the solutions are very closely related. They're kind of like, because if you are to put these in the calculator, I was looking for where one of these crossed the x-intercept. So that's what we were doing, because none of these are going to, they didn't give you both factors, so it's not going to make the parabola. But what you're doing is looking for where it crossed the x-axis. You're looking for a line that goes through an x-intercept. So these are going to make straight lines, and so we were looking for one that went through an x-intercept. But did this have an x-intercept? No. So this means that it was not factorable. There were no factors in that one. Interesting kind of version, right? Let's see. And so if you tried to factor this thing, it would have been non-factorable. Let's see, which one have we not done? Oh, yeah, 18. What are the solutions to this thing? It is quadratic, but you could still put it in insolve if you want to. It is an equation. You could put it in insolve. It will give you one of the 2 answers, but won't give you both of them. So sure enough, when we put it in insolve, it came up saying that x is 2. And if you go look over here, not a 2, not a 2, not a 2, but there is a 2 in this one. So you could just assume off this that there was only one answer that matched it. Had there been 2 answers with 2s, then you would need to graph it for sure. Now, if I want to graph this thing, I got to get 0 on one side, right? Because that's going to be where my y equals goes. So I need to subtract 81 on both sides. So when you put it in the calculator, you have your y equals where the 0 is, and then you've got your x plus 7 squared, and then just do a minus 81, because that's what I did on this side. I subtracted 81 and subtracted 81. So there's a minus 81 at the end of that. So if you graph it, it looks something like this, and it did cross at 2, but it also crossed at negative 16, so that's why that one matched. So whether you did the graphing version of it or whether you put it in insolve, either way you should have gotten that answer, right? Okay, so 2 different ways of checking it. You could have tried to eliminate answers with insolve first, and then if you needed to go back, if there were 2 answers that had a 2, you could have checked the graph itself. Which function is equivalent to this one? Well, if they're equivalent, are they going to make the exact same picture? Yes. And all of these are in y equals, and that one's in y equals, so I don't even have to solve. I just put them all in the calculator, put this one in first, and see which one of these goes right on top of the graph of this one. And it's always nice when it's the very first one that does that. So that did work. And this was what value of x makes the equation true. So we're just solving this equation. And I checked it this time. They were all x's, so all I got to do is put it in insolve, comma x at the end, close the big parentheses, and then go see which one it is. Well, it told me x is 2.2, so it's not the negative answers. And it's not the whole numbers, right? And it's not the negative answer. So the only thing that was left was 11/5. If you put 11 over 5 in the calculator, it does equal 2.2, so they do match up. So I always kind of double check that to make sure my fractions work. I didn't type in something wrong. So there was that page. Now let's go to the next page. 21. We have a systems of equations, a whole bunch of different sets of two equations. I got a picture with two lines on it. Which system of equations does the graph represent? All you got to do, and they're all in y equals, so I can just put them in the calculator, look at the picture, right? So go to the, now you could also do the solving version, but you don't have to because they're all in y equals. You could literally just match the picture. So if you go to the graph icon, put the graph in, put one in, hit tab, put the other one in, see if it makes this picture. If it doesn't make that picture, cross it off. Clear it off, go back to again to the graph icon and put both equations in, see if it makes the picture. So one is just matching the graphs. You could have also gone to LinSolve and looked to see where they intersected, and they intersected somewhere between negative 2 point something and 1 point something. So they were not at a pretty point, they were kind of negative 2 point something and positive 1 point something. So you could look to see if any of these intersected at that kind of location. The easier one on this one was just to go graph them since they're all in y equals format. And these two made that exact same picture. Okay, let's see over here. This is just what appears to be the domain, right? Does it stop at both ends? It does. Remember, domain are my x numbers, so I circled the x-axis. These are the numbers I'm picking out. I am not picking out any number on the y-axis. And these are x numbers, so get rid of anything that has y's in it. So I got rid of b and d. And then, of course, the x number goes over to -1, and it goes all the way over to 3. So I want all the x's between -1 and 3. What's the only one that had those two numbers? A. Let's see. Which expression is equivalent to square root of 96? Oh, these are really gimme questions. Put this in the calculator, find the number. Put each of these in the calculator, find the number that matches. And 4 times the square root of 6 makes the exact same number as the original one did. So remember, you put all 4 of them in because you could have 2 that match, and you want to go with one that has the least smallest number inside the radical, the most simplified. Let's see, this one. Yeah, we did that one. If a graph line passes through the ordered points this and this, what is the slope? So we're looking for slope. They gave you 2 points. Look at the reference sheet if you need to, and that will jog your memory that you can do y minus y over x minus x. So plug in the 2 y numbers, make sure you put them on top. If you start with this point on top, you start with this one on bottom. And then just put it in the calculator and hit enter. And I think it comes up and says 15/7. I think it matches it exactly. Okay, and it was a positive number, so you got rid of the negatives, and of course it did match the 15. Last one down here is which of the following is a function. This just says represents y as a function of x. That's just asking which one is a function. So remember, on functions, you look at the x's only and see if they repeat. If they repeat, it is not a function. And so the x numbers are the first ones, and you can see that -2 is repeated, so it's not a function. Now, mapping diagrams. This is saying that -3 is paired with 18. So that's saying that -3 and 18 go together, right? So you can make them into a set of ordered pairs if you want. -1 goes with 2, 0 goes with 0, 2 goes with 8, and 3 goes with -18. Did we ever have 2 arrows coming off of any of these? No. Had we had 2 arrows coming off, that would be 3 was paired with 18 and 3 was paired with 8. But they didn't have 2 arrows coming off, so each of the x's were only used 1 time. So I'm kind of thinking this is my function. If you look at the table, those 2 x's repeated. And if you do a vertical line test on a graph, if you're touching 2 points, that means that x number was used twice. That x number got used with that point, and that x number got used with this point. So used twice, not a function. So it failed the vertical line test. So which was it? It was G. There we go. Hopefully these are getting a little bit easier, and you're thinking of ways to match them up in the calculator and look for the easy way to do these. There will be hard questions on the STAR test. You don't have to do them, but you always want to look for the 30 easy ones and go through the test the first time, see how many that you know how to do, whether they're easy or hard, and maybe just at the end go back and count and see how many you got. And if you're already over 30, you know you passed, in which case go back and just see if you can get a couple more. If you're close to 40, see if you can get up to 40. If you're close to 50, see if you can get up to 50 that you know are right. 30 will get you passing, 40 will get you a B, and 50 will get you A or commended. So that's kind of what you're shooting for.